In this video, I want to show you what it looks like if you're solving a system of equations that ends up being inconsistent or dependent. I think your textbook does a great job showing you what it should look like for an independent system, but mathematically it can be a little strange when you end up with these inconsistent or these dependent systems of equations. So let's look at what these end up like when you're solving these. And so let me put up a system of equations. Oops. Y there equal to 1, and then we'll have x minus y equals 2. And depending on how your equations are written, it can be really obvious that they're going to be inconsistent or dependent, but sometimes it's not super obvious. And so let's say we're working on this using substitution to solve, so that means I want to solve one of these for y. So let's take this top one. I'd end up with negative y equal to negative 5x plus 1, and then I don't want that negative, so I'll multiply negative 1 through to change those signs. 5x minus 1, and I have this equation, solve for y, that I can substitute back into my other equation. And so if I'm putting that in to this equation over here, 5x minus 1, and so notice I did use those parentheses. That's because we're subtracting y, but y is equal to all of this. I need to subtract all of that. So that means I end up distributing that negative through as I solve this, so that would become a plus 1 right there. What happens here, we have this 5x minus 5x. Oh no, that turns to 0 and my variable just canceled out, leaving me with 1 equal to 2, which is not true. That is a false statement right here that we end up with. And so what that tells us is that this is an inconsistent system of equations. Right, and so that means if I were to graph these, I would end up with parallel lines. And much easier to see if I happen to solve both of these equations for y, like I did the top one. So if I take this bottom one and solve it for y the same way, getting rid of that negative, changes those signs. I can see right there they have the same slope, which tells me they are going to be parallel lines. And so if I can see that they have the same slope, I don't even need to solve my system. I can tell right away this is an inconsistent system of equations. But if I don't see that slope right away, I may not recognize it. And then as you do this process, you'll end up with a false statement with these inconsistent systems. The next type I want to show you is if you end up with dependent equations. And so most of the time dependent equations are really obvious right away because they're the same line basically. But maybe you have your equations written something like this, right? And so they're written in different formats, they look a little different, and you may not recognize right away that these are the same equations. They're the same lines. And so if that happens and we start to solve this system of equations, which is already set up nicely for substitution, I can put this right in for y right there. And so again with that negative, I'm subtracting the whole thing, so make sure you include some parentheses and distribute that. Negative 6. And my variable cancels off again. Goodbye to my x's right there, but I end up now with a true statement right here. And so a true statement tells you that these are dependent equations, and that means they are the same line. And we can see that if I were to solve this top equation for y, 2x minus 6, and then get rid of that negative, I can see right there, oh yeah, those are the same equations right there. They're the same line. But if you don't recognize that right away, you'll end up in this situation where you have a true statement, and that tells you that you have dependent equations right there. All right, hope that helps you out a little bit if you're having trouble recognizing those or any issues with that.